Hello, my name is Charlie Wallen, and today I will be talking about parental care in seahorses and how it affects their offspring. So, first, let's talk about parental care in seahorses. Well, it's male only, which means male is the sole carrier of his offspring. It's also a male pregnancy. Females deposit eggs into the brood pouch during mating and courtship dance. Pouch closes immediately after mating. The embryo is attached to the vascularized lining, forming a placenta-like system, which we see in mammals. So what are the impacts on the offspring? Well, brood size has an effect on offspring survival rate. More competition when in the embryonic stage. Male pouch size also has an effect on offspring. Larger size is associated with greater fitness and is favored by both natural and sexual selection. So when do these impacts actually come into play? Well, let's discuss the correlation between brood size and survival in offspring. In the first graph, we can see the old parent group has a much larger brood size than the young group. And if we actually look at the next graph, it shows survival percentages during ages week 1 through week 6 in old and young groups, young being black circles and old being white squares. As you can see, the young group drops off significantly while the old group is pretty much linear. Why is this? So if we look at this next graph, this could be a possible explanation why. Again, old and white, young and black. This graph represents height in millimeters through ages 1 week through 7 weeks. This can give us more insight on why the old parental group's offspring survives more often. More mass could equal better chances to survive in the wild. So now that I've shown you all this data, what does this actually mean? Older parents have a much higher success rate with their offspring. This can be due to larger pouch sizes, which can provide respiration at a better quality. But what does respiration have to do with anything? Well, embryos have a high metabolic demand, especially in late stages of pregnancy. Or it could be due to less competition for the best quality attachment sites within the pouch for the most functionally advantageous sites. As I said before, embryos have a high metabolic demand, and less competition means more nutrient-rich sites these embryos can attach to. Male seahorse's pouch essentially turns into a respiratory organ, which in turn provides an ideal internal environment for embryonic development. Lastly, I want to share some final thoughts. Male pregnancy, while strange, can provide embryonic seahorses with a nutrient-rich environment, helping them survive in early life, in turn, helping the reproductive success for the parents. And here are my references. So this first one explained male pouch sizes and how nutrients affects young seahorses. And this last one is my graphs. So thank you so much for listening.